This is the Anthrobiology Podcast, hosted by me, Gabby LaPera. Every 2 weeks, I interview a biological anthropologist about what makes us, us. Hello, everyone. Welcome to another episode of the Anthrobiology Podcast. Joining me today from the University of Saskatchewan. I got a good nod. Oh my God, I said it right. I'm so proud of myself. I've got Dr. Boughner. How are you?
I'm good, Gabby. How are you? And please, Julia. Please
Julia.
call me Julia.
Oh, thank you so much. Well, yeah, please call me Gabby. I don't know what else you would call me, Miss LaPera.
I don't know. Awesome.
I love that. When I was teaching in grad school, one time one of my students asked me, "You're getting your master's, so should we call you like Mistress LaPera?" And I was like, "Please don't. Like, absolutely not."
I think it's maters or something. There's some like fancy term that I should know, but I don't. But it is awkward. It's an awkward title.
I'm like, no, I don't need that. You can just call me Gabby. Also, I'm only, at the time I was like 2 years older than them. I was like, I'm good, thanks. Well, I'm very excited to have you on today because you do evolutionary and developmental research on teeth, which is very interesting and very exciting. I love teeth. I think they're really interesting. Every time I go to the dentist, I think he gets a little bit annoyed because I just like pepper him with fun facts about teeth. And he's like, I know, I'm a dentist. So I'm excited to be talking to someone else who's as excited about teeth as I am. Or maybe that's the other way around. Maybe
I'm excited to talk to someone who cares about teeth too.
Good. So yeah, I've given like a little like kind of like soupçon of what you do. Do you want to talk a little bit about your research in more precise terms?
Sure. My research program in my lab is, I guess, kind of three-pronged-ish. We have a more hardcore Evo-Devo prong, which is where we're looking at gene expression and cellular mechanisms in the development of the face and teeth. And we use different animal model systems to do that. So usually that's mouse. We have a mouse mutant that actually doesn't develop teeth, but its jaws develop normally. We are branching off into fish. Because some fish have teeth in their mouths as well as in their throats, kind of like that alien, like the xenomorph that shoots at that jaw from its throat. And then we also are branching into frogs as well. So like very comprehensive Evo-Devo in that sense, looking at molecules. Then we have a more primate-centric prong where we're looking at skeletal materials of primates, human and non-human as well, like baboons and chimpanzees. And then I guess the third prong is looking at human materials directly. And that's, using just retrospective data sets from dentists to study wisdom tooth impaction.
Yeah, that's okay. You said a lot of words that are all very, very interesting. I guess the place that I think we should start is Evo-Devo. We did have someone on the podcast. If you're like really interested in this and you want to get another perspective on it, the Nathan Young episode. But I think a lot of people think about anthropology and they think about evolution and they think about it kind of by itself. And they don't think about the fact that evolution has spent all of this time shaping what we're going to look like generally, but like the specifics of what we look like, a lot of that is down to developmental stuff. And then that also gets into the realm of epigenetics, which is exciting. I don't know if we've talked that much about epigenetics on this show. But you really need both factors to understand why an individual or even why a group of individuals look the way that they do.
Yeah, exactly. That's the place I arrived at after I did my PhD. So my PhD was using geometric morphometrics, which, Nathan Young might have mentioned, because that's also his background too, which is basically fancy talk for studying shape using numbers, so quantifying what something looks like. So I did that using data from the skulls of chimps and baboons and bonobos. And I looked at how they looked. And then I hit this wall where I thought, well, good grief, I can't explain why they look how they look. without getting different kinds of data. And the different kinds of data that I needed were data about how genes act and are expressed and how they drive the tissue changes that make a chimpanzee look like a chimpanzee and a human look like a human.
Yeah, for sure. I think it ultimately comes down to genetics. And I think that as time has gone on in a lot of disciplines, a lot of people have realized it's not so much nature versus nurture. For example, it's nature and nurture. And the same thing is true of evolution and developmental processes. It's evo devo. It's not just one or the other. I do think, since we are probably going to talk a little bit about gene expression, I'm realizing, I think maybe it's worth talking a little bit about how genes work. I think most people know that genes are contained in DNA, and you get some from mom, you get some from dad. We're talking mammals here. I'm not gonna go into asexual reproduction. I'm not well versed in that at all. But yeah, you get about roughly half from mom and roughly half from dad. And the thing is with genes, they're complicated and they each can have effect on others. So like you can have like a lot of different genes acting on a lot of different things. So it's very rare that you have one gene that controls a phenotype. So that's like how the gene is actually expressed in your body. So say whether or not your earlobes are attached. It's very rare that you have a gene, like a single gene controlling a trait like that, but sometimes you do. Those are the ones that we use as examples when you're teaching 8th grade biology. And that's the Punnett squares that everyone is probably familiar and sick of. But the thing with genes too, so besides the fact that you can have multiple genes affecting like one trait, genes don't necessarily have to be all the way on or all the way off. So that's kind of where, for example, nope, don't have an example off the top of my head.
But gene dose too, right? Like you can have genes that are expressed at certain levels. And so the dose is like turning the dial on a radio or something like that. So it's like the genes, it's not binary necessarily.
Exactly.
And so, yeah, it is complicated.
Yeah. I think that's the theme of the show, is that nothing is binary.
Yeah, it's true. That's bugged me in a way my whole career, even as a student, where you would see these almost straw dog arguments set up of it's one versus the other. And then when you actually get closer down to the answer, you realize it's not one or the other. It's a combination of things. And then some other things no one even thought to think of at the time as well. So it's not binary and it's complicated, I think, are the take homes.
Yeah, but that's good because that means that we have things for people like you to study.
Exactly. Oh yeah. No, the puzzle is the pleasure. So
for sure,
it's true that the genes that the way that they're expressed, we think of that Mendelian Punnett square, and the mouse model that I mentioned, the mutant that we've got, it's non-Mendelian inheritance with that one. So we see mutants that are not in a 1/4 proportion or whatever the Punnett square would predict, and things like that.
Yeah. I think that this is actually something that the general public sometimes has a hard time with science, is that a lot of the narrative has been about like one versus the other, and like they think that there's an answer, when really, first of all, we're nowhere close to like what the actual final answer might be, but it's a lot messier than that. But like trying to explain non-Mendelian inheritance to a 10-year-old is a lot more complicated. And so you start with like the easier stuff to wrap your head around. It's just like with organic and inorganic chemistry. Like you start with the easy stuff and then you get into the stuff where it's like, oh yeah, there's a lot of rules that you learned before. They don't apply to this. Not anymore.
I never got even that far with organic chemistry. So
it's totally fine. You didn't miss anything.
Phew.
I actually, I managed to get my master's degree and realized I never took Bio 101. So I went to a community college after I got my master's in biological anthropology and took Bio 101. It turns out I didn't know anything about plants. There are just whole sections on plants that I missed.
Yeah, we're totally like mammalian centric and vertebrate centric, and yeah, the plant people, man, they are a humble lot. They do cool stuff, but it just doesn't get advertised as much as it needs to.
Yeah, for sure. Anyway, so very complicated, lots of different factors. And then like like we were saying, like there's the evolutionary stuff, like there's the stuff that's hard coded, but then like your environmental stuff can actually have an effect on your genes and how things are expressed. So let's talk a little bit, I think, about teeth now that we've told everyone that everything's very large and confusing and everything mixes together to create outcomes.
Yeah, I mean, teeth actually are one thing that are, of course, the phenotype is influenced by ecology. But it seems that unlike, let's say, insects, where there's that field Evo, Devo, Eco, where they look at how the environment influences the development of an animal, teeth are not influenced by the surrounding environment. Like they're pretty much hard coded. So once they start forming, they go for it, which is why you see in kids that even are very nutritionally deprived, the teeth usually start to form on time and they form generally properly, although there might be a few issues with enamel structure and things like that. So teeth are, in that sense, teeth are really cool because they are generally very buffered from a person's environment. And so what you see is a good example of what's happening with the genes.
For sure. Let's start, I think, even farther back and think a little bit about the evolutionary history of our teeth and why they are the way they are. Primates typically have incisors, canines, premolars, molars. Why do we have that kind of combination of teeth?
We inherited that combination from our mammalian ancestors. So some primates have more premolars and molars than others. And so, well, certainly premolars. So humans have what I refer to as P3 and P4, right? Which is confusing to non-anthropologists because they're like, well, there's just two premolars. Why are you calling them 3 and 4? But it's that reflection that, you know, ancestors of primates had 4 premolars, and the first 2 are the ones that are thought to have been lost. And then, it's really interesting to look back and see how many molars and premolars non-primate mammals have had in the past, and that there is this tendency towards losing teeth, not gaining teeth, although there are exceptions to that.
Yeah, I think for people who are not familiar with this, you can either take your tongue and run it along the back of your teeth, or you can look in a mirror and do this. But the way that dental anthropologists think about the mouth, and dentists too, actually, is they divide it into quadrants. So you have your left upper quadrant, your right upper quadrant, lower. And so starting in the middle and you're working your way to the side, you'll start with your I1, which is your incisor 1. And then if you're looking at this in text, if it has a superscript, so the numbers floating above, that means it's in the top of your mouth. And if you have a subscript, that means it's in the bottom. But you have 2 incisors, correct?
Mm-hmm.
And then you have your canine. Mm-hmm. And then you have your P3, P4, because remember, Julia, said that we are missing our premolar 1 and premolar 2. And then after that, you have your molars. And so most humans have 3 molars. Most, I'm going to say, because, you know, like you never know. Like sometimes you open a box and someone just has like, I don't know, like they've only got 6 cervical vertebrae instead of 7. Like it just, you know, there's natural human variation. But most people have 3.
Oh, you mean a bone box?
Yeah. Sorry, a bone box. Not like a box of cereal. That would be horrifying.
A box of chocolates. You never know what you're going to get.
Oh, no.
Only 5 cervical vertebrae.
Yeah, humans are like a box of chocolates.
Yeah, we really are. Yeah, no, it's true. Yeah, when you crack open that bone box, you can see all kinds of really interesting variation.
Mm-hmm. Mm-hmm. But for the most part, that's what you're going to have. You're going to have like, and this is just one quadrant, right? So multiply that by 4, and that's how many teeth you have. So different teeth do different things. And I think like the having all of these different types of teeth in our mouth is a reflection of kind of like the very varied diet that primates have.
Yeah, exactly. So, you know, mammals evolved from a reptile at some point, and then there was this diversification from more simple conical teeth that, we think of when we think of reptiles and dinosaurs and stuff like that, to the more, what I guess, complex, but no judging. Reptiles are, they have the teeth they need to do the job they need to do. But for mammals, we diversified in our diets and we exploited all these different ecological opportunities, which meant basically eating different kinds of foods. Because if everyone was competing for the same kind of food, that would be problematic, because you would all be competing for the same pot of resources. But then the mammals and the primates that were able to adapt and evolve different tooth shapes and types, like premolars and molars, got to dig into the foods that other animals weren't eating as much of. So they got to take advantage of these opportunities, and so on and so forth, right? Until you end up with, well, not until, it's not like we're the pinnacle, but if you're talking about human evolution, then you end up with a bunch of contemporary modern humans, 7.5 billion of us on the planet today.
Yeah, it's how we got to now. I think that, so a lot of your research focuses on molars, and specifically, like, you look at wisdom teeth, and also, well, let me back up. I should say one of the things that you look at is how we end up with the teeth that we do. And one of the things that I read about that I thought was really interesting, and I didn't know previous to reading your work, was about the inhibitory cascade model, which is this idea that the size of your first molar, so that's the one that's closest to the front, can determine how big the next two molars are. And this seems to be fairly true in other primates, but you've done some research recently that shows that that's not necessarily true in humans.
Yes, and that inhibitory cascade model that came out of Yucca Yarneville, Catherine Kavanagh, and Alistair Evans' collaborative work. That paper was published in 2007 on a mouse model. And mice have incisors and molars only. They don't have canines. They don't have premolars, which probably a lot of people know. And the molars in mice are a great model system for studying primates, right? Because we have molars, mice have molars. So that's why there's also a big focus on molars, because as an experimental model system, mice have them. So that ICM, or inhibitory cascade model, that worked really well in a rodent model system where the first, second, and third molars are developing really close together in time. So, they're next to each other in space, just like our molars are. But human molars, the first molar starts developing before birth in humans. The second molar doesn't start for another couple of years. And then third molars don't start for a few more years after that. So the inhibitory cascade model is this idea that you have signals, you have genes being expressed, you have molecules that are present, that are regulating the size of each molar as it starts to form. But the trick in humans is, where are those signals coming from when you have a completely formed first molar and it's not a soft tissue, it's not expressing genes? That's where I think we have a problem porting that inhibitory cascade model from a mouse model into a primate, especially a human.
Yeah, and I think that one of the things that probably most people are familiar with is that our third molars are, or can be, problematic teeth for us as humans in a way that they don't really seem to be for other animals. And I'm wondering if, like, maybe the disconnect from the inhibitory cascade model and our third molars, could that explain some of that?
I don't think so, actually. I don't think that, because that model is about really early patterning, where we call them organs, tooth organs. Teeth are actually the organ of a tooth is an excellent model for other organs in our bodies, because organs have very similar ways of developing very early on. So that inhibitory cascade model is all about setting up the size of the tooth crown before it even starts to be cast in dentine and enamel, which, once that happens, nothing is going to change in that tooth, just like, because it's basically almost set in stone, because enamel is the most mineralized tissue of the body. I think it's 97% mineral, something like that. So what happens with our third molars is really a problem with eruption. There is some work from my lab with my collaborators Garnet Pakoda and Denver Mercuri, and Denver's PhD thesis work found that third molars that start to develop later, relatively later for a particular age, they're more at risk of being impacted. So we're finding some sort of a connection between when your third molar starts to form and whether or not it gets impacted. But I still think that stuff is happening
later. What is impaction, real quick?
Yeah, so that's a great question because it depends how you define it. But I think the best definition for our conversation is a third molar that doesn't erupt properly. That could mean that it gets stuck turning, facing the second molar in the jaw, like deep in the jawbone. It could also be the case where some listeners may relate to this, where your third molar erupts halfway and part of it sticking out of your gum, but the other half of it or whatever other part of it is still beneath the level of the gum. So it basically means your third molar didn't erupt completely into a way that you can chew with it. That's what we can consider impaction.
Got it. I know a lot of people who have had their molars removed, me included. I actually don't really know if I needed them to be removed. Actually, I don't remember.
Same with me. Yeah. I actually, when I was shown x-rays of my third molars, they were at quite an angle relative to where, you think of teeth erupting straight up, through the jaw. And I remember the oral surgeon pointing at the x-rays of my third molars and saying, oh, look at how tilted they are. These are definitely going to be impacted. And my parents and I said, oh, yes, we must take them out. Yes. But, knowing what I know now, I know that wisdom teeth often typically don't start developing. It's true with all molars. They don't start developing facing upwards in the direction they're going to erupt. They can face in different directions. And I kept my wisdom teeth because I am that person. and I saw how much of the crown was formed on the third molars, and it wasn't a lot at all. So actually, I kind of think that my third molars still had a lot of time where they could have rotated. The crown was still forming, and maybe I didn't need to have mine taken out. But here we are. I got them all taken out at 17.
Yeah. I also remember getting mine out at 17. But yeah, I think about that a lot. And I think that one of the things that you hear in dental offices all the time is like, oh, our jaws are shrinking. That's why we have to take the third molars out. Our jaws used to be bigger. Is there any insight that your work can shed on that statement, which is a very vague statement if you think about it?
It is. There's kind of a lot of pop sci around it. And it makes sense because, I think people are generally interested in faces and teeth and food, right? But so if you go to other parts of the world where people have a different culture, where their food is not as heavily processed and industrialized, and they're eating tougher food from a younger age, the instances of malocclusion and impaction of wisdom teeth is a lot lower. It's kind of the exception, not the norm. So I think it's really cultural. I think it is technological and cultural, where in Western countries where we give kids really soft foods as a norm instead of an exception from a young age, there's just this threshold of jaw growth that we're not meeting. It's like, if you're malnourished, you may not hit your max possible height that you were genetically programmed to be able to hit. I think it's a similar thing with jawbones, that we're just not maxing out jawbone growth. And that means that we're losing maybe, I don't know, I'm just spitballing, but a few millimeters. And that could make the difference potentially between a third molar that has the space to erupt and a third molar that doesn't.
Yeah. So this is something that should be familiar to longtime listeners of the show, which is that bones respond to stress put on them. It's never gonna, well, I'm not going to say never because it depends on the stress. So at the very far ends, it could affect the shape of the bone. But the shape of the bone isn't necessarily going to change. It's like the robusticity and the actual dimensions of the bone could change. And I think that that's what we're talking about here, right? So like if you're eating harder things, you're putting more mechanical stress on the jaw, which could cause the jaw to respond by becoming more robust and larger.
Yeah, exactly right. That's exactly right. And then the work that Denver was doing about the timing of when a third molar starts to develop, that also we think might have an effect because if a third molar is there, I mean, just think of it as like being in line early. If you're there in line early, you've secured your spot and you've made yourself known and no one else is occupying that space. And it might be that third molars that start developing earlier are also kind of muscling into that jawbone and maybe giving it a bit of biomechanical feedback and saying like I'm here and I need some space. Whereas if you're late to the party, then the room's already full and it's really hard to find space for yourself in there.
I guess, when do third molars typically erupt?
They can erupt. Wow, that's an interesting question. I'll back up and say they can start forming between the ages of about 8 and 12. So it's, a 4-year stretch. And they can start erupting late into your teens. But some people, their third molars actually will erupt into their early 30s, I think is the latest. 32, 34 are the latest ages that I've heard where third molars can erupt.
Yes, I have a coworker who is currently halfway through getting her third molars pulled because they did in fact come up at a funny angle and they are in fact causing her pain, and it's been a horrendous story to follow. But yeah, I think it's definitely really interesting because like both of us got our teeth pulled at 17, which is not anywhere close to like being done probably.
No, exactly. Like I think that it's probably really late teens, early 20s, that the third molars will erupt in people. But you can tell there's a lot of variation in when they actually come up.
So I think that another question, so we're talking about like we're evolving to have smaller jaws. That's something that you hear in the dental office. I think that it would be useful to talk about like, are we actually evolving to have smaller jaws? And when we say evolving, I think it's important to remember that we're talking about a change in the frequency of genes in a population. So are we selecting for smaller jaws in humans? Is that a thing that's actually happening?
Yeah, so that's where it's a really interesting case study of evolution. Because as I mentioned earlier, there's 7.5+ billion people on the planet. And now we have things like modern dentistry. And there's, people still actually will die of sepsis from a tooth abscess or something like that, right? But it's rare. It's pretty rare. And when that happens, everyone's aghast because we think, oh my God, it's modern times with dentistry and medicine and hospitals. So there is really low selection pressure for teeth that erupt properly. Because also when you think about it, people will go through puberty before their wisdom teeth would even erupt. So you could ostensibly have 1 or 2 or 3 kids before wisdom teeth would even take you out of the gene pool if you had some sort of infection because of an impacted third molar. So, even in a population where we didn't have access to modern medicine and dentistry, it might not make a difference then either. And now we do have all of that at our fingertips. So again, the selection pressure to make evolution guide a population to look a certain way isn't really, I don't think, a factor for wisdom teeth and jaws, because that's, you asked about jaws getting smaller. I think it's just that there's so many of us that there's so much more variation that's allowed now, maybe allowed in quotation marks, right? Just because we're not being selected out of the gene pool. That's it. More humans, more variation, more culture and medicine, less deaths from things that otherwise might have led to people not passing on genes for smaller jaws or wonky wisdom teeth or what have you.
Yeah. I think, that totally makes sense to me. I think that the answer is that we haven't stopped evolving. We've just stopped having as much pressure on certain features to disappear, really.
So, we're such a fascinating species because culture is such a driving force, I think, in our biology, more so than any other primate that we're aware of. So, I think that, like with wisdom teeth, what is influencing that is culture and technology and behavior. So, yeah, we're always evolving as a population, maybe just not in the ways that we traditionally think about it, with animals being, selected for really heavily because their coats aren't white like the snow, like a polar bear kind of thing.
Yeah, for sure. And again, right back to the beginning of the show where we're like, yeah, it's not just evolution or just development, it's both. And then we're also going to throw in culture, because you're right, culture is a huge factor for humans. It's something that the way that culture is passed between humans is differentiating. So it is going to affect our biology ultimately. It's really interesting stuff. I also want to be very cognizant of your time. So I guess my question now is, do you have anything that you wish that I had asked you or that you would like to say?
Oh, I'm glad you asked, Abby. Thanks.
Yeah, no problem.
Well, I think that just continuing with the thread about human evolution is worthwhile. I have a colleague who is in the College of Education at the University of Saskatchewan. His name is Tim Boughner, and he teaches science to teachers or students in the college who are going to go on to become teachers in the public schools in Saskatchewan. And so he includes evolution in some of that and how to teach science. And so he has said this phrase I really like. And he says, not understanding evolution is like driving without knowing you're in a car. And I love it because I think once you appreciate how evolution works, you suddenly see the world around you in a very different framework, and you start to be able to identify the mechanisms that are driving changes in populations, including humans. And so, it's the ability to suddenly see the car around you. And we see that with COVID, right? Because the ignorance, the lack of education around evolution is dangerous.
Yeah.
Because people, if you teach people evolution, you have to also teach them a bit about DNA. You have to teach them a bit about genes. You have to teach them maybe even a bit about stuff like mRNA. That was the basis of the vaccines. And you might happen to pick up a bit of knowledge about viruses and how they work. And so not understanding how viruses evolve and not understanding how selection works. And I think that really has literally been dangerous to people, because people have not been armed and empowered with the understanding about evolution at just a fundamental level. Of course, they don't have to be expert, but I think if we did a much better job of teaching kids from kindergarten about evolution, they would be much better informed citizens, and they would be much better prepared to deal with the kinds of things that we're now going to see more regularly, including pandemics. But there's also all kinds of other really excellent things about knowing how evolution works, which is, understanding humans and human populations, understanding things like wisdom teeth and how they may or may not change, your jaw. And when your dentist tells you that human jaws are getting smaller, like you might all just have a better, more informed understanding about how that would go. And, biotech, all kinds of opportunities open up when you understand genetics and evolution. So I think that's my thought of the day, which is just that I think also evolution is a bit of a bellwether for democracy, because it's interesting that in countries where you have authoritarian and totalitarian regimes, it seems that one of the first things to go, in addition to something like critical race theory, is ouch, is evolution, is teaching people openly about evolution so that they can make their own decisions and think critically about what they want to take away from an understanding about how evolution works.
Yeah, I think that's really interesting. I hadn't really ever thought about it, but evolution, there's like certain tenets that just provide you a framework for understanding a lot of things. So if you understand the basics, you can look at a situation and kind of, I guess, interpolate backwards. Like, what are the factors at work here? Or even extrapolate forwards. Like, so what does this mean going forward? It's like kind of teaching you the rules to a game. But the way that that game ends up playing out is different every single time, but at least you already know what the rules are. That's a very interesting way of looking at evolution that I had never thought of. And you're right. Like once you know the rules, you can apply it to so many different situations.
Yeah, I love how you said it's like knowing the rules of the game. And I think that you can be gamed if you don't know those rules. Like that's the flip side to that is that it's happening whether you acknowledge it or not. Some people are going to take advantage or some people will just be able to do things you aren't even aware of. And if you had that information, you could make better choices.
Yeah. And I think that understanding just genetics, just straight up genetics, is going to become increasingly important as biology and technology increasingly become intertwined. I say, as someone who lives in the epicenter of biotech. Yeah, that's really, really interesting. I think if anyone's listening to this and they're like thinking about how do I talk about evolution with people, actually I did an episode with Professor John Marks about creationism. I think that would be a really interesting resource for you. I think I also did an episode about science communication. It can be hard to talk about science with other people, and you shouldn't beat yourself up if you're having a hard time with it, because it's not an easy thing and we haven't figured it out. And a lot of the times, I see this with this show, a lot of the times the people who want to learn about it are very self-selecting, and you're not reaching the people who don't know. You're reaching the people who already know and want to know more.
Yeah.
That's a problem that we have to continue to think about and hopefully solve, because I think you're right. An informed populace is the best populace.
Mm-hmm.
Okay. Sorry. Now that I've gone completely off the philosophical rails here, it's time for our last 3 questions. Are you ready?
I'm ready.
Okay. If someone wants to learn more about the kind of work you do, what is a good starting place for them to read?
Are you going to have links
Yes.
to this podcast? Okay, awesome. Because I can give you a link to an article that I wrote in 2018. It was published in The Conversation Canada. And you probably already know there's The Conversation insert country here. So I wrote an article called Bad Molars, and it's about the evolution of molars. So that would be a really good place to start because it's very broad for the public consumption. And then if people want to geek out a little bit further, then there's 2 books that I'd recommend. And the first is by Peter Unger, and it's called Teeth, A Very Short Introduction. And it's part of this series of books, a very short introduction to blah, blah, blah. So that one's great. And then Tanya Smith, who was on your show, right? And she probably mentioned her book, which is The Tales Teeth Tell. And that one is another really nice exploration of the different facets of tooth development and dental evolution, especially in primates.
Facets, it's a pun, if you like teeth.
Yeah.
And it's an excellent book, and it's beautifully illustrated. I highly recommend. I know a lot of people just do Kindle stuff nowadays, and that's totally fine. I get that. But I would recommend buying the hard copy of this book because there's full color photographs that are spectacular and really, I think, help you understand the topic at hand a lot better. Peter Unger is also a classic. Mm-hmm. Anyway, and that also all of your recommendations were so good. Your article is also excellent. I read it in preparation for this interview and I was like, what a clear explanation of how molars work.
Oh, thank you so much.
You're welcome.
We can post that link too.
Totally. So second question, what are you reading for work right now?
For work right now, I am reading primary research literature around craniofacial development and genetics, and it's like hardcore developmental biology.
Fun.
Yeah, it really is. And I started getting into literature on ions and electrical signaling in development. I think it's a newer field of basically looking at how electricity influences developmental processes. And so I am just looking forward to getting my mind blown.
That is so cool. I've never heard of that. I am going to go Google that as soon as we're done. Third question, last question. What are you consuming for fun right now?
I am a bit of a dilettante, or I have a little bit of a touch of the ADHD or ADD with my reading. So I usually read like 3 books at a time, but I swap between them. So I'm reading a combination of Alicia Garza's The Purpose of Power. So Alicia Garza is one of the founders of the Black Lives Matter movement, and that is a really insightful, interesting book. And then the other one I'm reading is more kind of light fare, but still really important, I think, which is part of the Goodnight Stories for Rebel Girls series. And they have a newer book on immigrant women. And so that's like women who've just gone from one country to the other, not just women to the US or women to Canada. And so that's really fun because that's packed with one-page stories about women who've immigrated and made some, really interesting impact on the world. And then the other book I'm reading is Nick Hayes. He's a British journalist, a writer, and he's done a book called The Book of Trespass, which is about, he goes roaming on farmers' fields and estates in Britain, and he writes about colonialism and how the British Empire and the patriarchy has set up the system where the public doesn't own public lands anymore, and they get sectioned off for the uber elite and the wealthy, and this idea of the one percenters controlling so much that really belongs to everyone.
That's really interesting. I haven't read that book. I am currently reading a book called On Trails. It's by Robert Moore. It's a few years old now, but it's kind of a meditation on trails, how they form, why they're there. And he approaches it from an evolutionary, biological, and then cultural perspective.
Oh, cool.
It's super interesting. But there's a section on the book where he kind of like thinks about the fact that there are some places with like huge amounts of undeveloped land that aren't accessible to people because they are also private. And then, like, for example, in California, you throw a rock and you find a public hiking trail. So it's definitely, it's super interesting. I love that. My other book I just finished is Kitchen Confidential by Anthony Bourdain. I'm also a 2 book at a time. And I just started a book. I don't know the title. It was a Kindle deal. It was like $1. I think I'm going to get about $1 worth of enjoyment out of it. So I'm not even going to recommend it.
That's fair. Yeah, I've been meaning to read Kitchen Confidential for like literally years. So at some point I will get to it. But yeah, I've heard it's really good.
I think if you've ever worked in the service industry, it's something that still rings very, very true today. It was definitely weird reading it, knowing that he eventually committed suicide, and like seeing him talk about the things that, like, his demons. And when he finished the book, he felt like he was in a much better place. It's definitely, there's a lot of emotions that happened when I read that book. But anyway, thank you so much for spending an hour of your time with me. I really appreciate you, and your research is fascinating. Thank you.
Well, thanks, Gabby, for having me and for doing this podcast to help communicate, content that we love. We love the biological anthropology. And so thanks for helping put that out there in the world for more people to discover and hopefully fall in love with.
Thank you so much. Thanks for joining me for this episode of the Anthrobiology Podcast. If you have questions or comments, you can reach me at gabby.lapera@anthrobiology.com. That's spelled GABY.LAPERA@anthrobiology.com. This show is produced by me. Music courtesy of Chad Crouch, aka Poddington Bear at Sound of Picture.